Hi everyone, I just wanted to create this short video to supplement Dr. Soper's video. This video talks about some common design problems that you might run into as you are designing databases. Dr. Soper touched on one of these, which was missing values or null values, but there are a few other issues that I want you to keep in mind as we move toward designing databases. The first is the multi-value, multi-column problem. This occurs when multiple values of an attribute are stored in more than one column. In the screen you see an example of an employee relation, which holds information about the employee number, the employee's name, as well as the license plate numbers of multiple automobiles. You can see this might be a problem because you don't know how many automobiles any given employee might have. What if they have more than 3? Will there be a way to store the information about all of their automobiles? This is an example of a multi-value dependency. If you read the additional material about fourth normal form, you'll be familiar with this problem. But even if you don't know all the details of fourth normal form, you should watch out for this issue. Whenever you see that a relation is set up in this way, you need to break the tables apart even further, or in other words, normalize even beyond Boyce Codd normal form. In this case, you would want to create a separate auto table or car table so that each automobile has a record of its own with its own unique license plate number. Then this table would also have a foreign key field that could relate the automobile back to the employee. In this way, no matter how many automobiles the employee has, there's a good way, consistent way to store information from them. Another issue you'll run into is inconsistent values. These can occur when different users or organizations or data sources use slightly different forms of the same data. So you'll see here, there's any number of ways that you could store this product description about a small sofa or small couch. Spelling can also be an issue. You really run into problems when these are foreign or primary keys. So if we have a foreign key that is referring back to small sofa or small couch, or that is spelled the wrong way, then you're not going to be able to relate those tables together. The solution then is to enforce referential integrity constraints. In our first homework, we already saw how to do this with access. In this way, if you've misspelled something or typed a product description in a different way than it exists in the table that you're referring to, then your DBMS won't allow you to save that data. The next issue I want to make you aware of is missing values or null values, and Dr. Soper did a good job explaining these. In a database table, such as in SQL Server, if you have a null value or a field that is empty, the DBMS will actually show you in uppercase letters the word null. So this is different from a 0 or a space character blank space. It means that that field is completely empty. Now the problem is that this is ambiguous. If we have a field that is called date of last childbirth, for any given record, that field might be empty for any number of reasons. It might be because it's inappropriate, because we're talking about a male person. It could be that even if it is a female, it would be appropriate to have a value, but that value is unknown. We don't know when the last time was that person had a child. Or it might indicate that it's appropriate and known, but the data just has never been entered. It's missing. So there's no way really to know what the meaning of a null value is. So as we go along and over the next few weeks, as we're talking about designing databases, I would like you to keep in mind this idea of null values. When you're thinking about attributes to put in each of your tables, think ahead on what reason someone would have to leave a null value in that field, and try to make it more obvious in the way that you set up your table so that this doesn't become an ambiguous problem. Another thing that you can do is make fields required, which we also already had practice with in Access. Require the user to input a value. We haven't touched on SQL quite yet in our course this semester, but you can write this down as something that you can come back to. There is a keyword in SQL for you to check for null values. The final issue I want to bring up is the general purpose remarks column. A lot of times in spreadsheets, in lists, in databases, you'll see a field or a column that is called comments, remarks, or notes. And this generally seems useful to the end user, except then it makes it very hard to query data from that table. It makes things very inconsistent, and it could be used in many different ways. So let's look at an example. Here in this table, we might be storing information about students, and then we have a comment field. Well, here in this comment field, the user has decided to talk about which courses that student has taken. Now, it would be a lot easier to access data from this table and to make reports and use SQL if we have this stored in a more consistent way. So rather than just putting this information in a generic comments field, it might be better to create a separate table that has courses and relates to students, so that it's not quite so inconsistent and murky and vague. So those are the 4 issues that I want you to keep in mind. Anytime that you're creating a database table, think about, okay, could the user put anything generic, any generic comments in here? Might the user have any reason to leave it blank or null? Is there a possibility that someone will want to put multiple values in that field? And should we break it out? And if you think about all of these things, then you're more likely to create relations in your database that are more useful and consistent.